In this video, I'm going to explain to you how to find the limits of a function of the form 0 by 0 form and infinity by infinity form. That is, if limits x tends to a phi x by psi x is of 0 by 0 forms, where the limit of the numerator is 0 and the limit of the denominator also is 0, then in that case we have to apply this L'Hopital rule to evaluate the limit of this type of function. Now, if limit x tends to a phi prime of x by psi prime of x exists, that means if you differentiate the numerator separately and the denominator separately and take the limit of this one as x approaches a, then in that case, if the limit of this function exists, then in that case we can say that limit x tends to a phi x by psi x will be equal to limit x tends to a phi prime of x by psi prime of x, which is equal to phi prime of a by psi prime of a. So provided the limit x tends to a psi prime of x, this one is not equal to 0, or we can provided this one psi prime of a is not equal to 0. Okay. So now here, if you have a function of the form phi x by psi x, and if the limit of this one x as x tends to a is of 0 by 0 form, then we can apply this L'Hopital rule. And in some cases, you'll see that limit x tends to a phi prime of x by psi prime of x is still of 0 by 0 form. Then you can continue to differentiate the numerator for the second time and also the denominator for the second time. And if the limit of that one x tends to a phi double prime of x and psi double prime of, by psi double prime of x exists, then in that case limit x tends to a phi x by psi x will be equal to limit x tends to a phi double prime of x by psi double prime of x. Now the second form is of this one, infinity by infinity form. If limit x tends to a phi of x is infinity and limit x tends to a, the denominator psi of x is also infinity, and if limit x tends to a phi prime of x by psi prime of x is or x is in this case, that means if you differentiate the numerator separately and the denominator separately, and if the limit of this one as x tends to a exists, then in that case limit x tends to a phi x by psi x will be equal to limit x tends to a phi prime of x by psi prime of x, which is equal to phi prime of a by psi prime of a. So we'll apply this rule now, form 1 and form 0 by 0 form and infinity by infinity form, in order to evaluate the following problems. So here you can write evaluate limit x tends to 0 e to the power x minus e to the power minus x minus 2x whole thing divided by x minus sin x. Now you can see this function, it is of the form phi x by psi x, where phi x is e to the power x minus e to the power minus x minus 2x by x minus sin x. So how to evaluate this one? By using that L'Hopital rule. So now here you see that if you substitute x equal to 0 in the numerator, then it will become e to the power 0 will be 1, e to the power minus 0 also will be 1, 1 minus 1 will become it will be 1 minus 1 minus 2 into 0. So you will get in the numerator 1 minus 1, that is 0. And in the denominator also, if you replace x by 0, then it will be 0 minus sin of 0 will be 0. So this one is of the form 0 by 0 form. So now if it is of 0 by 0 form, then we can apply this L'Hopital rule, that is the first form, by differentiating this one, the numerator separately and the denominator separately. So let us see now. Solve this one. Limit x tends to 0 e to the power x minus e to the power minus x minus 2x divided by x minus sin x. This one is of 0 by 0 form. Okay. So therefore, by L'Hopital rule, limit x tends to 0 e to the power x minus e to the power minus x minus 2x divided by x minus sin x is equal to limit x tends to 0 Now differentiate the numerator separately. Differentiation of e to the power x will be e to the power x itself, and then differentiation of e to the power minus x will be minus will come out, so you get it as plus here plus e to the power minus x minus 2, because differentiation of x will be 1, so you get 2 only. And in the denominator, if you differentiate the denominator, what will you get? Differentiation of x will be 1 minus differentiation of sine x will be cos x. Now again, let us see whether this one is still of 0 by 0 form or not. You can see from here that if you replace x by 0 in the numerator, so what will be the value? It will be e to the power 0 will be 1 plus e to the power minus 0, that will be 1. So 1 plus 1 will be 2. 2 minus 2 will be 0. So the numerator is again 0. Now what about the denominator? If you replace x by 0, then cos of 0 will be 1. 1 minus 1 will be 0, which is still of 0 by 0 form. So you can continue to differentiate the numerator, which is of 0 by 0 form again. So this will imply that limit x tends to 0, e to the power x minus e to the power minus x minus 2x divided by x minus sine x is equal to limit x tends to 0. Now differentiate this one. If you differentiate this one, then you get e to the power x itself, e to the power x, then differentiation of e to the power minus x will be minus e to the power minus x, differentiation of 2 will be 0. And in the denominator, differentiation of 1 will be 0, and then differentiation of cos x will be minus sine x. So here this one is equal to limit x tends to 0, e to the power x minus e to the power minus x by sine x. Again, you can see that this one is again of 0 by 0 form, because if you replace x by 0 in the numerator, then it will become e to the power 0 will be 1 minus e to the power minus 0 will be again 1. So it will be 1 minus 1, 0. And if you replace x by 0 in the denominator, then this is a sign of 0 will be 0. So you can write here which is of 0 by 0 form again. So you can continue to differentiate. So in this case, by applying that L'Hopital rule, so e to the power x minus e to the power minus x minus 2x divided by x minus sine x, this is equal to limit x tends to 0. So differentiate this one, then what will you get? It will be e to the power x, differentiation of e to the power x will be e to the power x, and differentiation of e to the power minus x will be minus, so it will be plus here, e to the power minus x divided by cos x. So let us check whether this one is still, whether the value of the denominator is 0 or not. Now as x tends to 0, the denominator will become cos of 0, so this will be 1, and this is also a finite number. E to the power 0 will be 1, e to the power minus 0 will be 1. So which is no more of 0 by 0 form, so you can substitute the limit. It will be limit x tends to 0, e to the power x plus e to the power minus x, whole thing divided by limit x tends to 0 cos x, using the quotient rule of limits of function, and this is equal to e to the power 0 plus e to the power minus 0 by cos of 0, which is equal to 1 plus 1 by 1, which is equal to 2. So finally, the limit of this function, e to the power x minus e to the power minus x minus 2x by x minus sine x, is equal to 2. Now let me solve one more problem, which is of that second form. Infinity by infinity, infinity by infinity form. Okay, so let us evaluate this problem. Limit x tends to pi by 2 log of x minus pi by 2 whole thing divided by tan x. So let us find out the limit of this one. X tends to pi by 2 log of x minus pi by 2 upon tan x. Now just see this one. Through inspection, you can see that if you replace the value of x in the numerator, then by pi by 2, then we get pi by 2 minus pi by 2 will be 0. Then log of 0 is undefined, that is infinity. So that means the numerator is infinity. And what about tan of pi by 2? If you replace x by tan pi by 2, then we know that tan of pi by 2 is infinity. So this one is of infinity by infinity form. So solution will be limit x tends to pi by 2 log of x minus pi by 2 divided by tan x. So this is of infinity by infinity form. So by using this second form, rule of second form, then limit x tends to pi by 2 log of x minus pi by 2 upon tan x. This is equal to limit x tends to pi by 2. Again, just like in that form number 1, you differentiate the numerator separately and the denominator separately. So what is the differentiation of log of x minus pi by 2? It will be 1 upon, so you get 1 upon x minus pi by 2 divided by, what about the differentiation of tan x? It is secant square x. So this is equal to limit x tends to pi by 2, then it will become 1 by x minus pi by 2 into secant square x. Again, if you replace this one by pi by 2, then pi by 2 minus pi by 2 will be 0. So the sign of secant pi by 2 also will be 0. So in this case, what we can do now, we can again simplify this one in order to reduce it either to 0 by 0 form or infinity by infinity form. So what you can do now, it will be, you can write this one as 1 by x minus pi by 2, that one will remain as it is. Now secant square x can be written as 1 upon cos square x. So we can bring this one to the numerator, then you see that it will reduce to 0 by 0 form. So this is equal to limit x tends to pi by 2, then cos square x will come to the numerator divided by x minus pi by 2, which is of, now you see that if you replace x by pi by 2, then you get this one as cos square pi by 2, that is 0, and pi by 2 minus pi by 2 will be 0. So this one reduces to first form, which is of 0 by 0 form. And by using L'Hopital rule, you can differentiate the numerator and the denominator separately. So if you differentiate the numerator, you get 2 cos x into sin x divided by, if you differentiate the denominator, then this being a constant will be 0. Differentiation of x will be 1. So what will be the value in this case? So this is reduces to limit x tends to pi by 2 cos x sin x. Now since the denominator in this case is a constant, which is 1, so now you can directly substitute the value of x by pi by 2. So finally the value of this one will be equal to 2 cos of pi by 2 sin pi by 2, which is equal to 2 into cos pi by 2 will be 0 and sin pi by 2 will be 1, so it is equal to 0. So finally the value of this one, so this will imply that limit x tends to pi by 2 log of x minus pi by 2 divided by tan x is equal to 0. So you can see that by using this form number 2, you differentiate the numerator separately and the denominator separately. Since the limit of the numerator is infinity, the denominator also infinity. So you differentiate this one numerator and the denominator, then in this case you can reduce it to the 0 by 0 form, which can be evaluated by L'Hopital rule, that is where you can simplify again by differentiating this one, the numerator separately and the denominator separately, till the value of the denominator as x approaches to that particular value is not equal to 0. So you can see here that the denominator in this case reduces to 1, which is not equal to 0. Then you can substitute the value of this limit here as x tends to x by pi by 2. And finally, you get the limit of this particular function to be 0.